Hi, welcome to a series of getting started video tutorials for Roboanalyzer software. Roboanalyzer is a 3D model-based software that can be used to teach and learn robotic concepts. You can download it for free at www.roboanalyzer.com. In this video tutorial, I'll be discussing about inverse kinematics. Inverse kinematics refers to the use of kinematic equations of a robot to determine the joint parameters that provide a desired position of the end effectors. It involves the specification of the movement of the robot so that its end effector achieves a desired task. Now consider a general serial manipulator. Here this is the end effector and this is the fixed space. Now I want this end effector to be positioned at this point with some orientation. So this has to move to this point. So what should be the joint parameters so that this process can occur? So this is basically the opposite of forward kinematics. In forward kinematics, the task is to find the end effector's position and orientation while the joint parameters are given. Here what I mean joint parameters are the joint offset, joint angle, link length and twist angle. But in inverse kinematics, the end effector's position and orientation are given and the task is to find joint parameters. Well, this is the Roboanalyzer software. To get into inverse kinematics, you need to press icon button. A new window will appear exclusively for inverse kinematics. Now, you can choose the robots from this menu. Some of them are planar and some are 3-dimensional. To begin with, I am going to start with a simple robotic arm at 2 degrees of freedom robotic arm. So this is the figure, 2 links, 2 joints. Now in this end effector box, you can choose the x and y coordinates. So these are the desired position for the end effector. So I'm going to choose some random values, 250 and 50. You also have the freedom to choose the link length. This is for the link 1 and this is for the link 2. Now there are 3 cases. One, you can get multiple solution, you can get a single solution, or you can get no solutions. It all depends upon the input parameters. Now going further, the analysis is complete and I have got 2 solutions. So this is a multiple solution. So solution 1 and solution 2. Now when I press show button, these values theta 1, theta 2 gets updated to the main window. So basically theta 1, theta 2 are the initial values for joint 1 and joint 2. You can see it from here, joint 1, joint 2. Now you can verify the solution in 2 ways. Before that, let me simulate this and generate a curve. Okay. Yes. So as I said before, there are 2 ways. One, through the graph. Go to the end effector, this is the link 2, and look at the graph, end x and end y. Now the desired coordinates are 250 for x and 50 for y. 250, 50. Now zooming in. Yes. This is the 250 and this is the 50. So the solutions are correct. So the other method is through this. Save all the data to an Excel file. So this is the Excel file to which the values are saved. Now frame 1, this is the end x. I'm going to show it in some different colors, and this is end y. Yeah. Now you can see here from frame 1, 250 and 50. It starts at 250, 50 and moves further. So similar explanation can be given for solution 2. Now there is one more thing you need to know. You can choose the initial values and the final values. You can choose solution 1 to be initial and solution 2 for the final values. So okay, yeah, you can see these values getting updated onto the main window. This is the solution 1 and this is the solution 2. Okay, I'm simulating and getting a graph. So what you get is a closed curve, a two-dimensional closed curve, and the end effector and the graph for the end effector is like this. You can see the starting and the end values are same for both x and y. Now let us move on to a more comprehensive example. Let me move on to some three-dimensional robot, a 6R decoupled manipulator. As this is a three-dimensional robot, you can also choose the z coordinate, and you can also choose the orientation of the end effector, not just a position but also the orientation. You also have the freedom to choose some of the link lengths, joint offsets, and the twist angle. Now as I said before, it might have multiple solution, single solution, or no solution. It all depends upon the input parameters. The analysis is complete. So there are 8 solutions. Let me go for the solution 1. So it automatically get updated to the main window. You can verify the solution again from the graph. So you have 3 coordinates, end x, end y, and end z. You can see the starting points 1200 and 1200 for z, 100 for y, and 80 for z as expected. You can also try for other solution in the similar way. You can also choose the initial values, solution 5 and solution 8 as you wish, and it automatically get updated to the main window. The graph you get is again a closed curve. Yes. Yes, that's it. Thank you for watching the video.